Hey boys and girls, today we are going to be in our module 1 through 9 book, page 161, and we are continuing to work with our fractions, and today we are going to be subtracting and we're going to have mixed numbers. So we talked about mixed numbers yesterday. And we talked about what a mixed number is, how it is a whole number and a fraction. And sometimes whenever we are subtracting with mixed numbers, we need to rename them in order to subtract. And so we're going to learn how to do that today. All right, so this says Larry rides his bike to the park. On his way home, he gets a flat tire. How far does Larry have to walk to get his bike home? Write an expression for the problem. Okay, let's look at our picture. All right, guys, I think my video went out. So we're looking at our problem, and we know Larry went to the park, and we know that that's 3 1/4 miles away. And he was coming home and got a flat tire, so he went 2 3/8 miles. He almost got home. He's not quite there. So our first job is to write an expression. So we need to say we need to write something that's helping us figure out that right there. So we could say 3/4 minus 2 3/8 will help us figure out this part. Or you could say 2 3/8 plus something has to give us that 3 1/4. So that would be an equation, not an expression, but two different ways we could look at it. Okay. It says use fraction strips to represent the distance Larry rode to the park as an equivalent fraction with a denominator of 8. Then write a new subtraction expression. So in this case, they told you what denominator to use. Totally welcome to use your fraction strips if you want to. We've been using them for a little while, so probably we've got this. So I'm going to do this over here. And I like to rewrite it. So if they're both going to be 8s, this is going to be 3 and some amount of 8s minus 2 3/8. How many 8s are equivalent to 1/4? That would be 2 8s. So 3 2/8 minus 2 3/8. Do you have enough fraction strips to subtract the fractional part of the distance that Larry rode home? So it's saying right here we have 2 8s minus 3 8s. We don't have enough 8s right here. Our fractions, if I have 2 8s, I can't give you 3. So this is where we may have to start renaming our fractions to be able to subtract those. So we would say no, there are not enough. How can you represent the distance he rode using fraction strips so you're able to subtract the distance he rode before he got a flat tire? All right? So right here, I want us to think about this whole number. Now this fraction is split into 8s. This distance was measured in 8s. So that means this whole number is how many 8s? So I'm going to write some stuff out. One whole would be 8 8s, correct? Because 8 8s is a whole. So if I have 2 wholes, that would be 16 8s. Wouldn't you agree? Because 8 8s is 1. 2 wholes would be 16 8s. So 3 wholes would be 24 8s. So if I can go ahead and represent these as just fractions, just their fractional amount, then I'll be fine because there's more wholes in 3 than over here in 2, obviously. So if I made my 3 2/8 into only its fractional part, into just 8s, 8 8s, 16 8s, 24 8s, then I'm going to go ahead and put together my 2 8s. So that would mean that I had 26 8s. So what we're saying is 3 2/8 is equivalent to 26 eighths because we had 3 wholes, 8, 16, 24 eighths, 25, 26. We're going to do the same thing with these. Again, we know 2 eighths or 2 wholes is 16 eighths, 17, 18, 19 eighths. Now that I have renamed these mixed numbers as an improper fraction, so that's what they're called, improper fractions. We renamed them. We did not change the value. They are still equivalent, but we renamed them, and these are called improper fractions because the numerator is larger than the denominator. It looks kind of funny. It looks kind of improper. But now, since we've represented them in eighths, I can easily subtract them. So I have 26 minus 19. That is 7 eighths. And there we go. So our answer is 7 eighths mile. He was almost there, but he wasn't quite home. All right. So what we just did here, and one common mistake I see is my students will say, well, I'll just reorder it and say 3 minus 2. If you had done that, you would have gotten 1 and 1/8. Well, we know it wasn't that much farther away. We know it was not very far away. Don't ever switch around your values here in subtracting because that's not going to give you the same answer. All right, let's try some more. So turn to 162. The students in a 5th grade class and a 4th grade class ate some pizza. How many more pizzas did the 5th graders eat than the 4th graders? So we see pizza eaten by the 5th graders. I see all this. So I could say that's 1 whole, 2, 3, 4, 5. This fraction is split into 1, 2, 3, 4, 5, 6 parts. So I know 5th grade is 5 and a 6. I'm gonna write that right there. 4th grade is 2. Let's see how this is split. These are kind of hard to see on my copy. I think in your book you probably can. This is in thirds. 2 and 2/3. So our first job is to write an expression to model this. Remember it said, how many more pizzas did 5th grade eat than 4th grade? So how much bigger is 5 and 1/6 than 2 and 2/3? So one way we can do that is by subtracting 5 and 1/6 minus 2 and 2/3. And then it asks us to estimate the answer. So we need to look at 5 and 1/6. And remember, we use those benchmarks. Are we closer to 5, 5 and a half, or 6? If I have 1/6 and look here at our picture, that's helping us. I'd say that's closer to 0. Half would be 3/6. So I'm just going to estimate that to 5. And then let's look at 2/3. Is that closer to 0, a half, or a whole? Some may say half, some may say a whole. I'm going to go ahead and just round it to a whole. Remember, this is an estimate. Excuse me. So I'm going to say about 2 pizzas. Now in my picture, I can see there's about 2 pizzas right here, and then that was just that little spot. So that does look like a good estimate. So next we need to find a common denominator. Excuse me. Use the common denominator to write mixed numbers with equivalent fractions. So we're still keeping our mixed numbers with our equivalent fractions. Let's think about 6 and 3. Always look at the bigger one. Can 6 be a common denominator? Does 3 go into 6 evenly? It sure does. So I'm going to keep my 6. Then I'm going to have 2. So 2/3 would be how many 6? That would be 4/6. 3 times 2 is 6. 2 times 2 is 4. There are 4 6 and 2/3. You can subtract mixed numbers by renaming both to fractions greater than 1, or improper fractions, because when I look here, 1/6. I can't take 4/6 away from that. But I can use these wholes. This is an amount. This is a value. This is a part of my number. This is my whole number. So I'm going to go to the side again. And I like to just rewrite it. I like to have it. Let's think about it. If these are split into 6, so you always need to look and see what the fraction is. The one we did a minute ago was in 8ths. But this one is in 6 because it tells us that it's in 6. So 1 whole would be 6/6. 2 would be 12/6. 3 would be 18/6. 4 would be 24/6. 5 would be 36. Now you might see here and notice, remember I told you a fraction is a division problem? 12 divided by 6 is 2. 18 divided by 6 is 3. 24 divided by 6 is 4. 30 divided by 6 is 5. Fraction is a division problem. We are still representing that same amount in a different way. So 5 wholes would be 36 plus 1 more, so that would be 31/6. If I have 2 wholes, that'd be 12/6 plus 4 more, 16/6. Now I have more 6 in my first number. I can subtract them. 31 minus 16. 11 minus 6 is 5, and 2 minus 1 is 1. So my answer is going to be 15/6. Now let's think about it, because you probably wouldn't say that as your answer, like, oh, they ate 15/6 more. Let's change this back into a mixed number. So think again. This is a division problem. 15 divided by 6, or think, how many 6's go into 15? 2, and that would be 12. 13, 14, 15, there's 3 left. 2 and 3/6 could also be written as 2 1/2, because I know 3 is half of 6. So my answer, 2 and 3/6, or 2 1/2. Is my answer reasonable? Yes, I had estimated 2. 2 1/2 is very close to 2. So we're going to do some practice today and tomorrow for renaming our fractions, changing our mixed numbers into improper fractions. All right, I want to practice that a couple times on here. So I'm just going to make this up so you can use any kind of piece of paper. Let's say we've got 3 1/5, and I want to change it to improper. I want it to be just a fraction. So we need to think about it. We're in fifths. So 1 whole would be 5/5. 2 wholes would be 10/5. 3 wholes would be 15/5. I have 1 more, so that would be equivalent to 16/5. You can also note, you may notice a pattern. 5 times 3 is 15 plus 1 is 16. And the reason we're doing that is because we know there's fifths, 5/5 in every hole. So I have 3 holes, so 3 times 5 is 15 plus 1 is 16. Let's work backwards. What if I have 17/2 and I want to change it to a mixed number? I don't want it to be improper. So remember, a fraction is a division problem. 17 divided by 2. How many 2's go into 17? 2, 4, 6, 8, 10, 12, 14, 16. 18's too big. So 8 times, we know that's 16. 1 more would make it 17. 8 1/2 is equivalent to 17/2. Let's do another one. 2 3/4. This is in fourths. If I have 2 wholes, that means 4/4, 8/4, 9, 10, 11/4. Let's check it to make sure. 11 divided by 4. 4 goes into 11 2 whole times. That's 8, 9, 10, 11. Yep, that works out right. 4 times 2 is 8, 9, 10, 11. We can do it that way. All right, we will do, let me see how much time we got. We'll go ahead and stop there. Okay, so complete your homework for tonight, page 63, odds. Do your very best.